10.4, the Pythagorean Theorem. Pythagoras, by the way, was a Greek guy. And he is the guy who popularized this theorem, but not the people that came up with it. The Egyptians actually had it before him. If A and B are the lengths, that should say of, sorry about that. If A and B are the lengths of the legs of a right triangle. So first of all, this is something that gets spoken like in trivia questions and random parts of your life, and like this will keep on coming up. But I think we often don't really slow down to make sure people know the difference of what a leg is and what the hypotenuse is. Now, you know, this has to be a right angle, and that indicator tells you that that is a 90-degree angle. Whenever you see that box in a geometric problem, that's what it's telling you. Now, if I know that, you know, there's two legs and a hypotenuse when I'm dealing with a right triangle, then the only thing that really makes sense to me that can be the hypotenuse is the one side that's sort of unique from the other two. So go ahead and label that as HYP, hype. While this would have to be a leg, and that would have to be a leg. Now I'm labeling that on the inside, because if A and B are the lengths of the legs, then it doesn't matter which one I choose for A and B. I could actually reverse those. But it absolutely matters what I write for hypotenuse. C would have to be this longer length. And so I'll reread through this while writing the symbols for it. If A and B are the lengths of the legs of a right triangle and C is the hypotenuse, then the square of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So if you take one leg, square it, take another leg, square it, add them together, that is going to be equal to this side squared. And, the more you think about it, the more it makes sense, because this side is clearly longer. So if anything's going to add up to give you the longer side in some form or relationship, it's going to have to be those two guys. Okay, find the length of the hypotenuse of each triangle if... Now, this might seem totally unnecessary, but I would like to sketch this as practice. We have A, we have B, and I'm going to draw it so that A is longer than B. And I'm going to put A is equal to 8, and B is equal to 15. Now, when you're drawing these things, you don't have to be like crazy perfect, but doing these neatly will definitely help you figure out that there's my missing side, so obviously I'm trying to solve for C. Now look at this. All three of these problems here give you A and B, and are asking for C, which is the hypotenuse. Notice that that's different from these next problems where maybe they give you C and B but not A and C but not B, B and C but not A. So find the length of the hypotenuse of each triangle if A is B and B is 15. So I'm going to rewrite the formula for the Pythagorean theorem. This one's easier to remember usually because it gets repeated so much, but I still like to rewrite these so that I can see everything showing up beneath. 8 squared plus 15 squared gives me C squared. So 64 plus 225 is C squared. Then I will square root each side, and then I will end up writing C on here on the left as it goes away is equal to the square root of 289. And as you punch this one into your calculator, well, you'll get 17. And since this would be 17, it's not, measured in square units. 17 just represents the hypotenuse, so I'll write C equals 17 units. We don't know if this is feet or inches. You're probably fine making 2 and 3 on your own, and still make the drawings. So like if you draw 7 and 13, 7 should be longer than 13. Go ahead and do both of these on your own. I'm going to put the problems without drawings on the left and the right in just a couple moments. 5, 4, 3, 2, 1. So here's my answers. Let me mention a couple things. Notice that I went from here straight to 218. That's not too crazy as far as cutting corners goes. Especially like if you look at this, where I know 10 squared is 100 and 6 squared is 36. That's not crazy, like taxing on the working memory. And then also you have calculators for this part. However, I don't like it when people go straight from a squared to 100, because it's really important to have the habit of always showing your what you plugged in for these. Another thing, notice that this one didn't really simplify at all, but this one did. However, in these problems we are dealing with measurements, so it's often nice to go with some sort of decimal approximation. Here I went to the tenths place. If we were to use these problems in a multi-step problem, I think I would prefer to keep something like 2 square root of 34 or square root of 218, because then as I would reuse these, like I've said in the past, this would be exact, while both these are approximate. Okay, now let's see what happens when we are finding the length of the missing side. Meaning, it could be the hypotenuse, maybe not, and then if necessary, round to the nearest hundredth. So here they want us to go back 2 decimal places. Okay, now you probably felt like it was pretty unnecessary to sketch your triangle in the previous one, but I still want you doing it. And the reason I like you doing it is because here, as I write, 10 on one side, and then 25 somewhere else, I have to pay attention to that. C is going to be the hypotenuse. So here's 25 over there. Now, let's just fast forward to the end of the problem for a moment. Let's pretend you end up getting something over here that ends up being 8, which would be shorter than 10. It's really unnecessary to go back and redraw. But yeah, hopefully this side ends up being longer. But no major concerns there. Okay, as in the previous one, rewrite the Pythagorean Theorem. A squared and b squared equals c squared. And by the way, don't forget, this is not a right triangle. These problems only work if you have right triangles. So it's very important that you don't generalize this and try to make it work for everything in the world. So here's 6. Whoops, jump to the next one. In this case, we don't know what a is. So if you wanted to, it's definitely nice to write a equals question mark. Actually, go ahead and write that. So here we have a squared plus 10 squared is equal to 25 squared. Now, these problems kind of happen so much that they end up making you kind of practice less familiar squares. So I'm thinking this is 625. Let me check that in my calculator. Cool. I always try to plug in 525 for that one, but then that time I remembered. So here I have a squared is left equal to 525, and let's see what happens when we try to square root this guy. I ended up getting a non-whole number, decimal, so I'm going to write a is approximately 22.9, remembering that they want you to go to the hundredths, 22.91. And really it's not totally necessary to write units on these problems. Okay, that takes care of that one. Had we used this in a different problem, we might have turned this into 25, because that's a thing you can recognize, and then you'd end up with 5 square root of 21. Okay, if you were in the room with me, I would ask you if you wanted to see another example or not, because I'm not totally sure it's necessary. So I'll do it. A is equal to 6, C is equal to 14, and then B is equal to mystery number. So I'm going to write a squared plus b squared is c squared. I'm not even thinking as I write that, it's so automatic. and then write 6 squared plus, but here I do slow down because I want to be careful not to write 14 here. 14 is not the other leg. 14 is the hypotenuse, and that's always going to be on its own on the other side. So here's 6 squared plus b squared. The other thing too is if I go too quickly, I might think this is a 6 later on in a problem, is equal to 14 squared. Then I'll have 36, and b squared is equal to 196. Working towards getting b by itself, I have to first subtract 36. B squared gives me 160. Square root both sides, and b is going to be approximately 12.65. Now here's what I want you to do. I want you to get your calculator out, and I'm hoping that you're not having me do the work. And I want you to type in a couple of square root problems. Doesn't really matter what they are. But what I want you to do is I want you to use the second answer key, or just do whatever you need to pull up the previous one, and then work your way back, deleting these, so that it's giving you practice with being speedy. Because when you pull up the square root in a calculator, most of them do like that. Open up a parentheses, and then you could have 140. So I want you to use the delete key, working your way backwards, retyping 130. Delete key, working your way backwards, typing in 110, so that it's forcing you to, repeatedly do these problems and save yourself a little time. The third problem, definitely going to be an OYO problem, so I'm going to clear the ink and put up the final answer in 5, 4, 3, 2, 1. And so here's what I got. I ended up getting A is approximately 17.89 units, and this will stop this first video, but I'll point out a couple more things to you. Notice that I'm not always so crazy routine about labeling this as A, B, and C, but what I am pretty routine about is making sure I define the missing side. And what that'll do is that'll really discourage the most common misconception that you can just do so many of these problems that you're always just trying to find the right side. You have to make sure you understand what this formula is. And that's how the left leg, the bottom leg, or whatever the way the shape is arranged, is always going to give you this side squared on its own. What else can I say as far as misconceptions goes? Like there's common algebra errors going down from here. Maybe not paying attention to the directions thoroughly will take off a point here or there. I think that's about it to look for, And if you wanted to make it more challenging, keep in mind that you could later on find yourself applying these problems in a way to where you're solving without any numbers at all, which is kind of interesting. Okay, that takes care of 10.4, the Pythagorean Theorem, video numero uno.